Okay, we're going to talk a little bit about cryptography and different strategies that are used for gaining authorization, authentication, and non-repudiation of your files. So let's get started. We're going to explain what we mean by cryptography, the difference between keys and the length. We're going to explain how we pass them, what are the strategies for public key encryption, how we handle electronic signatures, and finally, the public key encryption authority for authentication. So, what is cryptography? It's basically a mathematical algorithm that is performed on a message that goes between two folks. Basically, what it tries to do is guarantee confidentiality in the communication. It's based on a key, and a key is a series of ones and zeros. And the idea is that you use the key to encrypt and decrypt. So to change it to the non-readable version back to the readable version. Authentication means that you can prove someone's identity based on the ability to unlock the key. If we're looking to validate the integrity of a message, then what we want to validate is the fact that in the transmission, it has not changed. So when we talk about these three things, confidentiality, authentication, integrity, we call that the CIA of cryptography, which means that it handles all of those properties. If the encryption is for confidentiality, then we want to make sure that the key that's used is kept secret. So it's only shared between the parties, and they know the key, but it's not given to other folks. The key is a series of ones and zeros, again, something the computer understands, and it must be kept secret. For a cryptanalyst to attempt to crack or find the key, they have to go through a lot of different iterations of combinations in order to figure out what the key is to unlock the message. Remember, the longer the bit length of the key, the harder it is to crack. So basically, the way it works is we take this key up here, we take the plain text message hello, we use the cipher key, we get the encryption of the message, we pass the message in its cipher form along the network to the recipient. The recipient knows the key, uses the key on the cipher message, and gets out the plain text. If we look at how a symmetric key works, it's based off what we might want to call a Caesar cipher. And a Caesar cipher basically has some kind of variation for what it is the letters are replaced with. So if we say we have a Caesar cipher of +4, that means the key N is replaced with R. C for cipher of +8 replaces all zeros with W, and so forth down the length. It's usually an easy one to understand to give you an idea of what's going on, but it's not a very good key. It's very weak and easy to break. So what we do is we look for ways to change some of the ciphers. And some of that may actually have to do with substituting one thing for another, and then not changing maybe all of the parts of the message. In most cases, ciphers use both what we call a substitution, where they replace one letter with another, and then they move them around. So there's an algorithm, a process that they use for getting through that. The ciphers can encrypt any message that's in ones and zeros. And what's nice about this is the way the encryption works, it is very quick. The codes are more specialized if they substitute one thing for another instead of a series of ones and zeros. But those types of codes, such as the Caesar cipher, make it easier for a human to understand. So if we transmitted the Japanese Naval Operation Code, and this is a simplified version of it, if we transmit it to say from Aki to truck, stop ETA 6 p.m., stop required BN, this is what the code would look like, okay? And these guys here, these stop messages, you notice how if these were both in the message with the same encryption, it might be easy for someone to start to figure out what's going on. So what they actually do is they use an encryption key of 100 bits, and by changing the size of the key, they're able to get different strategies for different words. Another thing that you look at is how long does it take for someone to decrypt a message. With the rise of machine power and the quickness that processes can be handled, shorter keys have been much easier to crack. In most cases, public keys are at least 1024 bits long, and even that's not considered a really good length, but it's pretty tight for someone. So what do we mean by symmetric key and cipher encryptions? Well, basically, we have different processes or different types of encryptions that have been built. The first one that was out there was DES, and DES was not considered a very strong key. It was very easy to break. Then they moved to 3DES, which basically took the key that they had and used another key on top of it to encrypt the message. The ones that you're seeing right now are more RSA, RC4, so you're seeing things with much more longer bits in order to allow a more difficult time to decrypt the message. So you'll also notice here that as we moved along these different messages, the length of the key became much broader. So basically, we take a 64-bit plain text message, and we take the 64-bit key, we add 8 redundant bits, and we put it through the decryption process and come out with the message. That's the message that would get sent across the network to the receiver. But as you've seen, the standards have changed. So we look for encryption more for confidentiality, but that's only one of the reasons why we use it. In many cases, we want to see that we have the ability to identify who sent the message and guarantee that the message hasn't changed. So in those cases, we may use a two-party system. Basically, the parties agree upon the cryptographic system to use, so which one of the processes, and each one begins the dialogue with a handshake. The two parties then engage in their communication using the cryptography protected communication, so that even if someone were to pick it up, if they don't know what the key is, it's difficult for them to figure out where to go. So they start with the handshake, okay? There's initial authentication. They exchange their keys, and then they start their message. When they finish up, they send what they call an electronic signature. And the electronic signature is also encrypted, basically for confidentiality. So they authenticate it and they guarantee its integrity. Then they sign it for confidentiality. And we'll talk about how that works. So let's stop for here.